Okay, so this video we are going to discuss October-November 2021 paper 1-1. Okay, so question number 1, they want us to expand this this bracket, all right? So to expand this bracket, it is just a normal type of expansion where you are having the bracket 1 minus 1 over 2x power 2. So that means you're having this bracket for twice. So you multiply them together. From here you have 1 minus 1 over 2x minus 1 over 2x plus 1 over 4x squared. And if you simplify it, then you have 1 minus 1 over x plus 1 over 4x squared. So this is how we expand it by just multiplying every single term in these two brackets. Alright, so for your information, this part, how are we combine them together? We combine it together like this. So you assume that you're having 1 over 2. That means you're having half apple, okay, negative half apple minus another half apple. Therefore, after you combine it, become 1 apple. So it is negative 1 apple. Right, then after that, we continue to part number 2. So for part number 2, they want us to expand the first 4 terms. Okay, for this particular bracket with power 6. Alright, so for this one, we can use binomial expansion or binomial theorem to expand it. So for the first term, it will be 6c0. First bracket is a 1, the second bracket is 2x. So the 0 will follow the power, will be the power for the 2x. Alright, so we are having the 6. And then we are having 6c1 power 1. So you can see that we increase the power for the x. Alright, so 6c2, then power 2 here. And we have to expand it up to 6c3 because this is our fourth term in this expansion. Okay, so this is the first term, second term, third term, and fourth term. Alright, so after you write out the correct formula, then you can straight away press the calculator and simplify to get the final answer. So your final answer should be 1 plus 12x plus 60x squared plus 160x power 3. So this is the first 4 terms for this binomial expansion. Okay, then now we continue to part C. Alright, so for part C, now they want us to find the coefficient of x for this particular expansion. So if you have a look in detail, for the first bracket here, generally it's actually the bracket that we expand in part A. And then for this second bracket, we actually expand the first 4 terms in part B. Alright, so we are going to use the result in part A and part B to get the answer. So I'm having 1 minus 1 over 2x squared and also 1 plus 2x power 6. I will try to bring in all the expansion that I did for part A and part B. So this is what I have. For part B, it is 1 plus 12x x squared until x power 3, right? Okay, so now to get what the question wants us to get, they are asking for the coefficient of x. Coefficient of x means that the x is with power 1. So for the first term of the bracket, okay, of the first bracket, we need to multiply with something with the x in the second bracket to get a term with x power 1. For the second term, you have to multiply it by using 60x squared. And for the third term in the first bracket, you need to multiply it with x power 3 so that you can get something with x power 1 after you multiply them. Alright, so I will just focus on how to getting the terms with x power 1. So 1 multiplied with 12x, I get a 12x. Okay, so negative 1 over x multiplied with 60x squared, you have negative 60x. And after that, 1 over 4x squared multiplied with 160x power 3, and I will have 40x. So from here, I will want to combine all the terms together for these 3 terms, and I will have negative 8x. And since this question is asking for coefficient, therefore I will write it out. the coefficient of x means that the number that is multiplied with the x, so the coefficient of x will be equals to -8. Right, so this is generally how we find out the coefficient for the x. Okay, so we come to question number 2. We are having a curve with this equation, and the line has this equation, and k is a constant. Alright, so they want us to find a set of value for k which the curve and line do not intersect. So when you're having a curve and a line, so this curve, generally it is like a parabola or the quadratic form equation. So the graph might look something like this, and the line is a linear equation, therefore it might look something like this. And when they say this curve and line do not intersect, generally we can apply the concept of discriminant, where it seems like there's no root, no intersection point means like no root for the equation. So we are having b squared minus 4ac, which is which is smaller than 0. All right, no intersection point means it will be smaller than 0 for the discriminant. So we are going to use this concept to solve this particular question. Right, so we are having the curve and also the linear equation. So just assume that we want to solve these two equations simultaneously to find out the intersection point. Therefore, I will let the equation number 1 equals to equation number 2. We assume like we want to solve the simultaneous equation. All right, and from here you can see that we actually not able to solve the quadratic equation, so we group all of them together to get a quadratic equation with 0 on the right hand side. Okay, so very obvious that this is A, this is B, and this is C. Since in the question they are using the keyword curve and line do not intersect, this is the reason that we are going to use b squared minus 4ac smaller than 0 to get the value of k. So b squared minus 4ac smaller than 0, this is my b, a is a k, c is 2 minus k equals to 0. Okay, then expand it. Sorry, this is k squared. Okay, then I'm having negative 8k plus 4k squared, which is equals to 0. So if you try to further simplify it, you will have 5k squared, and then minus 12k plus 4. Sorry, I should put it as smaller than 0, right? Okay, so this one should be smaller than 0, smaller than 0. This is also smaller than 0. Okay, so if I have a look for this quadratic inequality, I can further factorize them, become 5k and k, then 2 and 2, which is negative and negative, so smaller than 0. All right. Okay, so this is, we get two critical value where k equals to 2 over 5 and also k equals to 2. All right, so to get this to solve this quadratic equation inequality, so you can opt to maybe you can choose that to use number line, or you can draw the graph. All right, to find out what is the value of k that we need to substitute so that this whole equation is negative. So my critical value is here. So for the bracket k minus 2, it will be positive when all the value of k is greater than 2. So this is positive. For the bracket k minus 2, this is negative and this is negative. If you substitute any value from this part into the bracket k minus 2, it will become negative. Therefore, I put a negative here. So for this bracket 5k minus 2, we will know that if I substitute any value that is greater than 2 over 5, then this particular bracket will be positive. Therefore, I draw the line to the right hand side. So this is plus, plus, and minus. So plus and plus multiply with plus, you get a plus. Plus multiply with minus, you get a negative. Negative, negative, you multiply together, you get a positive. All right. So for this particular question, because we are looking for negative value, all right, smaller than 0, which is negative value, therefore we'll look for overall negative, which is this part, which means that our equation, our quadratic inequality will become negative if the value of k is between 2 over 5 until 2. All right, so this is how we get the value, the set of value for k lah. Alright, so this is how we solve question number 2. Okay, so we come to question number 3. Solve by factorizing this equation, and they want us to solve by using the factorization method. Alright, so the question already gives us a very obvious hint. Alright, you have to factorize it before you solve the equation. Alright, so if we have a look for this particular equation, right, generally you realize that there are 4 terms here, 1, 2, 3, and 4. But there's nothing common that we can factorize from all the 4 terms. Right, so when you're having this kind of question, generally you can try to factorize the equation by looking at first 2 terms and also the last 2 terms. So that means now I try to factorize the equation in half of the equation. That means I will focus on the first 2 terms first. So for these first 2 terms, if you look at it, generally we can try to factorize out the 3 cos theta. If I factorize out 3 cos theta, generally I'm having 2 tangent theta here at the first term, and this second term will become 1. So I'm having negative 1 here. Okay, so plus, I try to copy a plus. So for the second half of the equation, 4 tangent theta minus 2, there's something common that I can factorize out, which is the 2. So I will factorize out the 2, and therefore I'm having 2 tangent theta minus 1, which is equals to 0. Okay, so now, after I factorize the equation in the first half and the second half, then now I try to look at it as 2 terms. This is the first term of the equation, and now this is the second term of the equation. So look at first term and second term of equation, right? Generally, you can also see that there's something common that you can factorize out, which is 2 tangent minus 1, and also 2 tangent minus 1. Okay, so these 2 brackets are actually something common for the first term and the second term. Therefore, I can factorize it out as well. So 2 tangent theta minus 1. Imagine that if you pull out this whole bracket outside, okay, the equation, so the first term will become 3 cos theta. Same thing happen for this part. If you factorize out the whole bracket, then the second part here left the 2, and it is equals to 0. Alright, so after this step, you can see that we successfully factorized the equation out into 2 smaller brackets, and now we can try to solve them. So for the tangent theta, it will be equals to 1 over 2. For cos theta, it will be equals to negative 2 over 3. Okay, so now we can try to find out the basic angle for each equation here. So for tangent theta, the basic angle should be equals to 26.6. That means you press tangent inverse half, then you get 26.6. And I'm looking for the tangent positive quadrant. Tangent trigo function is tangent, and then this value is positive. So we are going to look for the tangent positive quadrant, and for our solution, it must be in this range from 0 until 180. 0 until 180 generally means that the first 2 quadrants that we have. Alright, so for the first quadrant, everything is positive. For the second quadrant, sign is positive. For the first quadrant, the answer for first quadrant is the basic angle theta. For the second quadrant, the answer should be 180 minus basic angle theta. Alright, so we are looking for tangent positive. So tangent positive means that I will accept the answer from the first quadrant, and I will ignore the answer from second quadrant. So for the first quadrant, to write out the answer is theta itself, which is the basic angle. Therefore, for this equation, the theta is 26.6. Then we proceed to the second equation here. First, I also need to find out the basic angle. Okay, so to find out the basic angle, we are pressing cos inverse 2 over 3. Ignore the negative sign. So cos inverse 2 over 3, I will get 48.2. To get the basic angle, we should always ignore the negative sign. Alright, the basic angle should be the answer in the first quadrant, so it should be always positive. So cos inverse 2 over 3, and you get 48.2. And now we are looking for cos negative. So in which quadrant cos is negative? First quadrant cos definitely is positive, therefore I don't want to answer from this quadrant. And now proceed to the second quadrant. In this quadrant, cos is negative. and I want to get the answer from this quadrant. So to get the answer for this quadrant, you take 180 minus the basic angle. So the theta will be equals to 131.8 degree. All right, so in short, we have two answers for theta, okay, for this equation where theta equals to 26.6 and also theta equals to 131.8 degree. Question number 4. Okay, so we are having the first term of arithmetic progression is A, and the common difference is -4. So this is actually our D, all right? Then the first term in a geometric progression is 5A, and the common ratio is -1/4, where this 1/4 is a R. They give us the information, sum to infinity of the geometric progression is equal to the sum of the first 8 terms of arithmetic progression. So from here, generally, we have one useful information where sum to infinity for geometric progression will be equals to the sum of the first 8 terms. So this is arithmetic progression, this is geometric progression. So by using this information, we can use it to find the value of A. Okay, so sum to infinity of the geometric progression, original formula will be A divided by 1 minus R. And from this question, we know that the first term for geometric progression is 5A. Therefore, this is 5A. And the R is -1/4. We replace the R, become -1/4. Okay, then for the sum of the first eight term, okay, for arithmetic progression, it will be n divided by 2, which is n divided by 2, 2a plus n minus 1d. 2a remain as 2a plus n minus 1 is a 7, and the d is given -4. Okay, so if you try to simplify and also solve this equation, eventually we will be able to get the answer for the A. Alright, so if I try to simplify, I'm having 5a over 5/4, and then I'm having 8a minus 112. So 5a will be equals to 10a minus 140. So if we try to simplify this, then my a will be equals to 28. So this is actually the value of a. Okay, then now part number B. Okay, so for part B, k term of the arithmetic progression is 0, and they want us to find the value of k. So the k term is tk, and it is equals to 0. So for the k term, okay, in the arithmetic progression, the general formula will be a plus n minus 1. So in this case, it will be k minus 1d, and it is equals to 0. Therefore, we try to substitute all the values that we know in this equation. So a, we already know that it is 28. K is the unknown that we want to find out, and the d is -4. It is equals to 0. So if we try to simplify this equation and solve it, we'll get the value k equals to 8. So this is how we get the answer from the information given in the question. Okay, so now question number 5. The diagram shows part of the graph for this equation. And then they're asking us to find out the value for the positive integer a, b, and c. So a, b, and c are all positive integers. Okay, so for this one, right, for this graph, the basic graph is actually cos x, and they actually experience a few different types of transformation. All right, so we need to know the value for a, b, and c. Okay, so first of all, the original graph for cos x from 0 until 2 pi, the original curve might look something like this, will look something like this. Okay, so original graph from 0 until 2 pi, right? The cycle of cos x should be one cycle. And if I look at the diagram provided, we can see that there are two cycles of cos x from 0 until 2 pi, which means that this is first cycle, and this is the second cycle. All right, and because of this, generally we can know that the value of B is equals to 2. Therefore, first answer, the B is equals to 2, due to the reason that we can see 2 cycles of cos x in the range from 0 to 2 pi. All right, so we can straight away decide that the B is equals to 2. All right, so now for the next value, the maximum value for original cos x is a 1, and the minimum value for the original cos x is -1. So you can see that the distance from the center line, which is x equals to 0, which is y equals to 0, is 1 unit and is to 1 unit for original cos x. If you look at our diagram, the maximum point is 8, and the minimum point, the minimum value is -2. Where if I want to know the amplitude of the graph for this part, generally what we need to do is like we can take 8, the maximum value, the maximum y minus the minimum y, and we get a 10. All right, so we divide the 10 unit into half. That means there are 5 units above and also 5 units at the bottom, okay, from the center line. Therefore, the A is actually equals to 10 divided by 2, which is equals to 5. All right, so A is actually the amplitude of the graph. All right, so it is a stretch factor 5. Right, so original graph, you're having 1 in front, okay, because of the y equals to 0, the center line to the maximum point is 1 unit. And now from the center line to the maximum is 5 units, therefore the A is equals to 5, where this graph, the original graph, experienced the stretching in y direction with a stretch factor of 5. All right, so after we decide the B and also the A, next one we are going to decide the value for C. So to decide the value for C, we can see very obvious that there's a plus C outside the basic function, which is cos x. So plus C, generally it should be a translation. So to figure out the translation, there are a few steps that, or maybe a few methods that you can solve for it. You can try to use the minimum point and figure it out, or you can try to use the center line. So original graph, for my center line, it should be y equals to 0. This is the center line, where from this center line, the top and the bottom, okay, have the same amplitude, which is 1 unit. All right, so if I look at this graph, I need to figure out where is the center line. Okay, so it can be 8 minus 5. All right, so if 8 minus 5, that means it is a 3, where your center line should be around here, which is x equals to 3. Sorry, which is y equals to 3. And you realize that original graph is x equals to, is y equals to 0. The center line is y equals to 0, and you are moving it up 3 units. All right, so from here, we know that the value of C should be equals to 3, where we try to translate the graph 3 units upwards. All right, so this is how we actually decide the value for A, B, and C for this diagram, or for this new function here. All right, okay, so this is how we solve it. Then we proceed to part number 2. Okay, so for part number B, for this value of A, B, and C, right, using the given diagram to determine the number of solution, okay, for this equation. All right, so when they're asking for the number of solution, and based on the equation, right, for this equation, generally you can see that the left-hand side is actually equals to the y in the diagram for both questions here. All right, so we have another part of the equation on the right-hand side. And if they are looking for the number of solution, generally we are looking for the intersection point for this y and also for the equation on the right hand side, where you need to try to sketch y equals to 6 over pi x. For y equals to 6 over pi x, if you let x equals to 0, you'll get value of y which is equals to 0. And if you let x equals to pi, then you have the value of y which is equals to 6. You can use these 2 points to plot on the diagram and try to figure out how many intersection points are there. Alright, so we're having 0, 0, this is the point. And we're having pi and 6, so pi and 6. Okay, so try to use a ruler to connect these 2 points together to get a linear equation, to get a straight line. Alright, so if your line is good enough, okay, is accurate enough, then generally you can see that there are 2 intersection points. Oh, sorry, there are how many intersection points? There are 1, 2, and 3 intersection points between the straight line and also the curve. So there are 3 intersection points here. Therefore, the number of solution will be equals to 3. Alright, so for this part, okay, for the line y equals to 6x over pi, and also the original graph y for in the diagram, they are having 3 intersection points, which also means that they have 3 solutions for this equation. Okay, then we proceed to part number B. B number 2. So same thing happened here. The left hand side is y equals to the original graph that we have in the diagram. And now we are going to consider the second graph, which is y equals to 6 minus 6 pi over x. Okay, so to sketch the line here, this is also a linear equation, right? So I need 2 points. So first I will let x equals to 0, and this gives me the answer y equals to 6. And if I let x equals to 5, this will bring me the answer where y equals to 0. So now I will plot these 2 points on the diagram and observe how many intersection points we have. Right, 0, 6, pi 0. Right, so I will need to plot the point 0, 6. 0, 6 means this part. And then pi 0 is here. Okay, so if I try to connect the line, these 2 points together by using a straight line, so you can see that there are first intersection point here, and this is the second intersection point. All right, which also means that for this particular equation and also the equation in the diagram, the number of solution is equals to 2. Why is it equals to 2? Because you can observe that there are 2 intersection points when you try to plot the straight line and also the curve. Okay, so this is how we solve this kind of question. Question number 6. We have a diagram and it shows a metal plate ABC in which the sides are straight line AB and the arcs AC and BC. So the line AB has 6 cm, the length 6 cm. AC is the part of the circle with the center B and radius 6 cm. So from here you can know that the arc AC is a part of the circle with the center B. So that means arc AC with the B, this is actually a sector. Alright, and we know that this is 6 cm. Therefore, the line CB, the straight line CB is also 6 cm, according to what we get from the question. Okay, then they tell us also AC, besides the AC, right? Then the arc BC is also a part of the circle with center A and the radius is 6 cm. So from this sentence, we also know that actually the line AC is 6. Okay, right, so I try to draw a straight line AC, and this is also a 6. So from here you can see that this triangle ABC is actually equilateral triangle, and that actually give us an idea that all the angle inside the triangle should be the same, which is 60 degree, or you can write it as pi over 3. So every single angle here inside the triangle ABC will be actually equals to pi over 3. Alright, so for the first part, they are asking us to find the perimeter of the plate, giving the answer in terms of pi. So to find out the perimeter of the plate, we will need to find out the length of arc. So that means I'm trying to find out the length of arc AC, the length of arc BC, and also the length of the straight line AB. So to find the length of arc AC, it is actually the arc of a sector, right? So it should be r theta. So r should be a 6, and the theta is the angle in the triangle, which is pi over 3. So the arc BC also the same, r theta, which is 6 multiplied with pi over 3, and the length AB is given straightforward, which is a 6. Alright, so they want us to leave our answer in terms of pi, so we just try to simplify and add all the terms together here. So we end up should have 6 plus 4 pi. So our perimeter will be 6 plus 4 pi cm. Alright, then now for the second part, they ask us to find the area of the plate, and our answer must be in terms of pi and sec3. Okay, so to find out the area of the plate, generally there are a few ways that we can do that. So maybe for me, what I can see is I'm trying to use the area of this particular sector. This is a particular sector. Okay, this is the area for a sector, and I want to add the area of a segment. So this is the segment that I shade it in the blue color. Alright, so this is how I plan to find out the area for the metal plate. Okay, so I will write it out. So for the area, generally I want to use the area of sector plus the area of segment. Okay, so for the area of sector, right, the formula is half r squared theta. So half r squared should be 6 squared, and the theta, just now we already know that it is pi over 3. To get the area of segment, generally you also need to take the area of a sector minus the area of triangle. Okay, so you should take the area of sector, you should take the area of sector minus the triangle, minus the triangle. Alright, so again, our step will be area of sector, which is also half r squared theta, minus the area of triangle, it will be half r squared, AB lah, AB means also 6 multiplied with 6, and then sine theta, pi over 3. Okay, so this is generally the steps that we should proceed with. Alright, so we are having 6 squared divided by 6. Therefore, I'm having 6 squared is 36, right? Okay, so 36 divided by 6, I'm having 6 here. 6 pi. Then plus, for this term inside, also 6 pi. And then for this one, I'm having negative 18. I need to get the value for sine pi over 3, where it should be sec 3 over 2. Alright, so if you further simplify it, we are having 12 pi minus 9 sec 3. And area is measured in cm square. Okay, so please take note that for this both question here, we have to leave our answer in the exact value. Alright, so this is the answer in terms of pi and also the sec 3. Okay, so we are now at question number 7. Right, so there's a circle with the center 5, 2 and pass through the point 7, 5. So generally we're having a circle and then the center is 5, 2, and also there's one point where it is 7, 5. All right, so very obvious, the center to uh, the point is actually the radius, right? The distance from the center to the point is a radius. Therefore, when you want to find the equation of the circle, we need to try to find out the distance between the center and also the point first. All right, so which is the radius? Okay, so to find the radius, generally is the distance of the point on the circle with the center. So I'm having x minus x squared plus y minus y squared. All right, and if I try to simplify, I'll have a square root 13 as the radius. Okay, then after that, I will substitute into the general equation, the standard equation for the circle, where we are having x minus the x coordinate of the center square plus y minus the y coordinate of the center, and we need to square it with the radius square. So if you want to further simplify it, you can rewrite again, become this pattern. So x minus 5 square plus y minus 2 square, and it is equals to 13. So this is how we get the equation of the circle. All right, after that, there's a line 5x minus 10 intersect the circle at A and B, and they want us to find the exact length of the chord AB. Okay, so generally, if let's say we are having a line and pass through the A and B, definitely we need to find out the coordinate for A and B first, and after that only we can proceed to find out the exact length for the chord AB. All right, so we will need to substitute the line equation into the circle equation. All right, so after substitution, my circle equation will become, okay, so for the y, I will replace it by using 5x minus 10. Therefore, I'm having 5x minus 10 and minus 2 square equals to 13. Right, and if I try to expand everything, this is something that I will get. So 25x squared minus 120x plus 144, which is equals to 13. Okay, so I try to further simplify all this, become a quadratic equation. Okay, so this is without the square. And further simplify it. All right, so okay, I think I can still further simplify again. Okay, so when I simplify until this part, I think it's quite easy for us to factorize it out. So I'm having x minus 3 and also x minus 2, where it is equals to 0, and therefore my x is equals to 3 and also x equals to 2. All right, so when my x is equals to 3, right, I want to find out the equation of y, the value for y. So substitute it into the linear equation, and we'll get the y in an easier way. Therefore, I get y equals to 5 and substitute x equals to 2 into the linear equation as well. So I will have y equals to 0, which means that this is one of these will be my coordinate of A and one of these will be my coordinate of B. So to find out the length for the distance AB, generally we have to apply the length formula, where we should have x1 minus x2 squared plus y1 minus y2 squared. So if you try to further simplify it, we'll have 1 plus 25, and therefore the exact length for AB will be 26. Okay, so this is how we get the length of the chord AB in the exact form. Okay, so question number 8. They want us to express this expression in terms of the completed square form, where A and B are constants. Alright, so let's start. Before we do any completing square process, we need to factorize the coefficient of x squared so that it become the coefficient of x, coefficient of 1. The coefficient it become 1, alright? And then factorize all the negative 3, and that's why I'm having x squared minus 4x. And after that, I need to start the process of plus something squared and minus something squared for the completed square form. Alright, so the something here will be negative 4 minus, negative 4 divided by 2. Therefore, I'm having negative 2 and a negative 2 here. The original plus 2 in the expression, I will just keep it outside. Okay, so when I try to factorize the first 3 terms here, when I try to simplify the first 3 terms here, it will become x minus 2 with a big bracket x squared and minus 4 plus 2. Alright, and after that, to further simplify it, I need to multiply the 3 with the first term, which is the bracket, and also multiply the negative 3 to the second term, which is negative 4. And I'm having negative 3 x minus 2 square plus 12 plus 2. And end up I'm having this as my answer, where negative 3 x minus 2 square plus 14. Okay, so this is the completed square form for my expression here. Okay, so next, there's a one-to-one function defined by fx. Okay, so fx is negative 3x squared plus 12x plus 2 for x smaller equals to k. And they are asking us to state the largest value of the constant k. Alright, so for my first part, when I completed square, when we're completing the square, generally we know that for this curve, it is an N shape because of the negative 3. Alright, so the A is negative value, therefore it should be an N shape. And then the maximum point will be at 2 and 14. So our diagram might look something like this. Okay, so our N shape might look something like this. Okay, so this is a parabola. And then generally this is 2. And this is 14. Okay, and how can we make it as one-to-one function? So to make it one-to-one function, we need to define a certain value for k so that it become one-to-one. Alright, so the largest possible value for k will be equals to 2 actually. Okay, because we can make it one-to-one if we consider only the left-hand side of the original graph, original parabola. Alright, so you can see that the largest value that we can have for the k will be the 2. Okay, so from here you can straight away state the value for k, which is equals to 2. Alright, so for the next part, and now k is equals to negative 1. They want us to state the range of f. So again, one more time, the original graph might look something like this. Okay, so our original graph might look something like this. So originally this is a 2, right? Okay, and now they define our k, which is negative 1. So that means if negative 1 means that this is the value of k. This is the value of negative 1. Let's say this is negative 1. And it means that x smaller equals to negative 1 means that we only consider this part of the graph in green color. Okay, so this green color graph is actually for the domain where x smaller equals to negative 1. And we actually want to find out the value of the y at x equals to negative 1. So we can try to substitute negative 1 into the function f. So we are having negative 1, and then original function will be this. And that's why we get the value negative 13. So since this is the value of negative 13, so maybe the diagram that I draw is a bit out. Okay, so that means graph might look something like this. So this is -1. Therefore, this value should be -13. So you can see that this is the range of my function, right? And therefore, when you write out the answer for the range, it will be y smaller equals to -13. Okay, so this is how we solve the part C. And next, let us continue to part number D. Alright, so for part number D, they want us to find the expression for F inverse. So to find the expression for F inverse, generally we have to use the completed square form. So our original function with the completed square form is in part 1, part A, where the part A is -3 and then x minus 2 square plus 14. Okay, so we will let y equals to this, and we want to express this equation become x in terms of y. So if I try to move it become x in terms of y, generally this is what we have lah. So I'm trying to move all the variable x to left hand side, and then simplify it, divided it by 3, take the square root both sides. So when we take the square root both sides, generally we need to consider both plus and minus sign. And after that, we are having 2 plus minus square root 1 over 3, then 14 minus y. Alright, so for here, for this part, generally we are having two possible answers. The first answer is 2 plus the square root of something. Another answer is 2 minus the square root of something. So how can I decide which is the correct inverse function? And to decide it, generally we have to look at the domain. Okay, we have to look at the domain of the original function. So we can see that from here. Okay, so let us have a look for the original domain, or the domain for the original function. So now they tell us that the k is equals to -1, right? Okay, k is equals to -1. So that means the original function is x smaller equals to -1. All right, so x smaller equals to -1. So you have to consider which of the function here will give us the value that is smaller equals to -1. So definitely 2 plus something the square root. This something the square root is always positive. So 2 plus a positive value, it will be always more than 2. So this function impossible to give us a smaller equals to -1. Therefore, our possible answer is this, where 2 minus a square root value, which means 2 minus a positive value, and it is possible for us to actually get a -1 value, a value that is smaller than -1. So this is our correct inverse function. Therefore, you can write it in this way, where the inverse function for the function f is actually 2 minus square root 1 over 3, and then 14 minus y. Right, so this is how we decide the inverse function, the correct inverse function. All right, so why do we need to have a look for the range of function? This one is actually the range of inverse function, and we actually learned before that the range of inverse function is equals to the domain of the function. So that's a reason why we need to refer back to the domain of the original function to decide the correct inverse function. All right, okay, then now let's continue further to the next part for part E. All right, so for part E, the result of translating the graph of y equals to fx by this translation is the graph of y equals to gx, and they want us to express gx in the form of px squared plus qx plus r, where p, q, r are constant. All right, so let me write out the original function for the fx first. So the original function will be y equals to, and then we are having -3 sorry, -3x squared Okay, so negative 3x squared plus 12x plus 2. This is my fx. Okay, so when we try to translate it into gx, generally we need to have a look what is the translation involved. Right, so they are going to move in y direction or vertical direction 1 units down, which means that the y we have to minus 1. Oh, sorry, I correct my explanation just now. This one is actually moving 1 units up. So when you want to substitute into the original y, generally you have to put in y minus 1, so that y is equals to 1 minus 1 equals to 0, and you get y equals to 1, which means that you are moving it 1 unit up. All right, and then for all the x, we are going to move all the x in this direction are 3 units to the left. Therefore, when you want to substitute inside the equation, you do the same thing like y, which becomes x plus 3 squared plus 12. All the x you have to plus 3. All right, then plus 2. Okay, and if you try to simplify all this equation here, expand everything. Okay, so if you try to expand everything and then try to simplify in details, generally you have y equals to negative 3x squared minus 6x plus 12. And therefore, this is actually the function after the translation where gx is equals to negative 3x squared minus 6x plus 12. Alright, so this is what you have for the function gx after the translation of fx. Okay, so now we are at question number 9. We are having the equation y equals to fx where it is given that f prime x is equals to this equation. Okay, so given that f1 equals to negative 1 over 3 and they want us to find the fx. So from f prime x to change it become fx, we need to apply integration. Alright, so to get the fx, we need to apply the integration of the original f prime x, where I'm having integration of 2x squared minus 7, then minus 4. I will want to change the 4 over x squared become 4x power negative 2. Alright, so I start the integration. Therefore, I'm having 2x power 3, the power plus 1 divided by the new power. Then for 7, integrate 7, you get a 7x, negative 7x. And then for x negative 2, the power plus 1 become negative 1 and divided by the new power. End up, we are having a plus c also. Alright, so to get the value for the c, we need to use the information here where the x is equals to 1 and this is the value of the y. Alright, so we are having negative 1 over 3. Substitute 1 into the equation. And we are having plus 4, then plus c. From here, we will see that we were able to get the value of c, which is equals to 2. Alright, so end up our complete function fx will be equals to 2 over 3 x power 3 minus 7x plus 4 over x plus 2. Alright, so this is what we have here. Okay, then after that, they want us to find the coordinate of the stationary point on the curve. So to find out the stationary point, generally we need to let f prime x equals to 0. Alright, and after that we solve for the value solve for the value x, and then we try to get a value for y from the original function fx. Alright, so if I let f prime x equals to 0, generally I'm having 2x squared minus 7 minus 4 over x squared, which is equals to 0. And I try to solve this equation. I will make the denominator disappear, where I should have 2x power 4 minus 7x squared minus 4 equals to 0. Alright, so generally for this equation, it is a quadratic form equation. Okay, so if we treat it as a quadratic equation, generally we can also factorize it like quadratic equation, but the x will become the square. Alright, so if I try to factorize it, I should have 2x squared plus 1 and then x squared minus 4. Continue further, you have x squared equals to negative 1 over 2, where definitely we all know that this should be no answer. Alright, if you want to take square root both sides, you won't get any value here. And we're having x squared equals to 4. Therefore, x equals to plus minus 2. Okay, so they're asking for the coordinates. So for coordinates means that you also need to get the value for y. So if x equals to 2, what is the value of y? So substitute the value of y. To get the value of y, you substitute it into this equation. Alright, and when x equals to 2, the value of y will be equals to negative 14 over 3. And then for x equals to negative 2, you substitute it also into the original function fx. The y should be equals to 26 over 3. Alright, so we can write in the coordinate form. So the coordinates of stationary points generally is this one. So we are having 2, negative 14 over 3, and also negative 2, 26 over 3. Alright, so this is the two coordinates of the stationary point. Alright, okay, then next, for part number C, they want us to find f prime prime x. Right, so again, I will write out the original function for the f prime x, where I'm having 2x squared minus 7 and minus 4 x power negative 2. So to get the second derivative, you continue the differentiation from the first derivative, where I'm having 4x. Differentiate the negative 7, you get a 0. And differentiate this one, you will have positive 8x power negative 3. So if you want to write in a better way, then you can write in the fraction form in this method. Alright, so this is actually my second derivative. Okay, alright, then now we continue to part D. Okay, so for part D, they want us to determine the nature of each of the stationary points. Alright, so just now we are having the two stationary points, the coordinate for two stationary points, where the first point is 2 and then negative 14 over 3, right? 2 and then negative 14 over 3. We substitute the 2 into the second derivative. So if you substitute the 2 into the second derivative, we are having 4 times 2 plus 8 divided by 2 power 3. So generally, we are getting a value which is 9, and this is positive value. So when your second derivative with the x coordinate is a positive value, generally it means that that particular point will be a minimum point. So you can write out like this. So this coordinate or this point is actually a minimum point. Alright, so the same thing happened for the second point at negative 2 and 26 over 3. Substitute the x coordinate into the second derivative of the function f. So we are having 4, negative 2, then plus 8 divided by negative 2 power 3. Okay, so the value that we get should be negative 9. And then you can see that it is a value which is smaller than 0 or negative value. So when you're having a second derivative with the x coordinate with the negative value, that means that that particular point is actually a maximum point. And this is how we solve this question number 9. Okay, so we are at the last question now, question number 10. Okay, they want us to find this integration. All right, so generally to find the integration here, there's a infinity sign. All right, so we can consider this as actually the improper integral. All right, so for any improper integral, before we start, I will want to make this expression, the fraction, become the negative power. So I'm having 3x minus 2 power negative 3 over 2. Okay, and then when I try to integrate it, I want to find out the limit of a to infinity, where I make the infinity become the a here, and then 3x minus 2 and negative 3 over 2 dx. All right, so if I try to integrate it in a normal way that we learned before, so integrate the bracket with a power, I will need to plus 1. All right, take the power plus 1, where it will become negative 1 over 2. Okay, therefore, I need to divide it by negative 1 over 2. After that, I need to differentiate the thing, the 3x minus 2 inside the bracket. So differentiate 3x minus 2, you get a 3. Therefore, you need to divide it by 3 as well. And the limit here will be a and 1. Okay, for me personally, I prefer to take out all the constant before I continue the integration. So if I take out all the constant here, I'm having negative 2 over 3. After that, you can see that the terms inside here will become more simplified. All right, so if I simplify, I will have 3x minus 2. After that, only I will substitute the limit a and 1. Okay, when I try to substitute the limit a and also 1, the value 1, a and 1, my equation inside will become 1 divided by square root 3a minus 2 and minus 1. Okay, all right, so try to assume that the a now is infinity. So when I'm having infinity times 3 minus 2 square root, it is still infinity. So 1 divided by infinity, I'll get a very small number. Okay, very, very small number. I will assume that it is 0. All right. If I'm having a 0 here, okay, so when I try to simplify my answer, and eventually I will get a value which is 2 over 3. So this is how I solve the part A. And now we proceed to part number B. For part number B, they give us this diagram as well, and the shaded region is bounded by the curve, the x-axis, and the line x equals to 1 and also x equals to 2. All right, and this is the equation. So the shaded region is rotated through 360 degrees about the x-axis. So the x-axis means that we need to integrate towards the x later. They want us to find the volume of revolution. Okay, so let us set up the question here. To find out the volume, generally you also need integration, right? Okay, so the formula for volume is integrate the limit and then pi y square x dx. Okay, so because of x-axis rotate through x-axis, therefore our integration should be towards the x, which is in this dx. All right, so now I start to put in and substitute in all the details. Okay, so pi is a constant, I will take it out. All right, so what's the limit for the x value? So you can see that the x value here is limit 1 from x equals to 1 until x equals to 2. So I'm having 1 and 2 here. And y squared. Y squared means I have to square this function. When I square this function, eventually I'm having 3x minus 2 power 3 and dx. All right. Next. before the integration, it will be great if I make it become a negative power when having negative 3x minus 2 power negative 3 for the whole bracket. Okay, so to integrate this, I copy the pi, which is a constant, and now integrate 3x minus 2, I copy the bracket. For the power, I need to plus 1, so I'm having negative 2 and divide it by negative 2. I need to differentiate the thing inside the bracket also. So differentiate 3x minus 2, I get a 3. So I divide by 3. And after that, only I substitute in the limit. Okay, so again, for my own practice, usually I prefer to take out the limit first. The constant first. Then only I will substitute the limit in. So I'm having negative pi over 6. And then the terms inside, right, the expression inside will become 1 over 3x minus 2 squared. And I want to substitute in the value for 2 and 1. So when I'm having negative pi over 6, substitute in the 2. So 3 times 2 is a 6. 6 minus 2 is a 4. 4 squared is a 16. So I'm having 1 over 16. And after that, I substitute the 1 into the equation. So 3 minus 2 is a 1. So I'm having 1 here. Alright, so if I try to simplify it, I will have actually 5 over 32 pi as the answer. Okay, then this is volume. Therefore, I'm having units cubed. Okay, so of course, for this particular question, right, generally they didn't ask for exact value, right? So they only ask for volume. If you want to change it, become 3 significant figure also can as your answer, which is 0.156. Alright, so this is how we solve for part B. And now let's continue to the last part, the part C. Okay, so for part C, they are telling us that the normal to the curve at this point across the y-axis at point A. Alright, so they want us to find the y-coordinate of A. So here the keyword is the normal to the curve. Okay, at this particular point, cross the y-axis at point A. So maybe at first we need to form the normal equation first. Okay, so what is the curve equation that we have in the above part? So original equation for the curve is y equals to 3x minus 2 power negative 3 over 2. So to form the normal equation, generally we need the dy dx to get the gradient of tangent first. So we need to do the we need to get a differentiation first. All right. So for the differentiation, for the power, you put it in front, become negative 3 over 2. Copy the bracket and the power you minus 1. So power negative 3 over 2 minus 1 become negative 5 over 2. And after that, you need to differentiate the thing inside the bracket. So differentiate 3x minus 2, you have a 3. And you multiply with the 3. Alright, so if I simplify, I'm having negative 9 over 2, 3x minus 2, power negative 5 over 2. Okay, so I want to get the gradient of tangent at 0.11. So at 1 and 1, the x coordinate is a 1, right? So we substitute 1 into the dy dx. Therefore, I'm having negative 9 over 2. So we should know that this value, negative 9 over 2, is actually the gradient of tangent. Okay, but now we are interested in the gradient of normal. Okay, we want to form the normal equation. Therefore, since we know that the gradient of tangent multiply with gradient of normal should be equals to 1, right? Sorry, it should be equals to negative 1 because they are perpendicular to each other. Therefore, the gradient of normal should be equals to 9. 2 over 9. Okay, so once I know the gradient of normal already, I can form the equation of normal.
So how to form the equation of normal? We are having the passing point. The passing point for the normal is 1, 1. So to form the equation of normal, I'm having y minus 1 equals to gradient, which is 2 over 9, and then x minus 1. So this is the equation of normal, all right? And after that, if you go back to the question again, they are saying that the normal to the curve cross the y-axis. So when the line cross the y-axis, it means that x is equals to 0. So we can substitute x equals to 0 into this point. Okay, substitute x equals to 0 into the equation of normal, and we will get y equals to negative 2 over 9 plus 1, where the y is equals to 7 over 9. And this actually is the coordinate of the point A. All right, so the point A coordinate will be 0 and also 7 over 9. Okay, so here we solve all the questions for this paper. All right, so thank you very much for watching.